All right, hello there. So today in class we covered these notes right here, and I wanted to give you, help you start on your homework just a little bit. I'm not going to, do the problems for you, but just so you can get a little bit of a start in case, this is some more difficult things. So anyway, on problem number 1 right here, you need to notice a couple things. You need to notice that your x squareds match. So that means that your horizontal asymptote is going to be the leading coefficients. And the leading coefficients are 1, so 1 over 1 is 1. So your horizontal asymptote is 1. That means that you will not have a slant asymptote. Okay? All right, so try to factor this. So my problem, when I factor it, the x squared minus 9, that's perfect squares. So you got x plus and x minus something. And on the bottom, you got x squared plus 4x plus 3, so you're going to have all pluses because it's all positive, and then you're going to factor that. Well, let me tell you that one of these items is going to cancel. So this is going to cancel right here, therefore creating a hole. So the thing that cancels is x plus 3. That means your hole is going to be at negative 3. So that means that there is a hole, yes, and it's going to be at negative 3 comma something. So to find out what the hole is, what you need to do is, after this part right here cancels out, when you got that factored and figured out, if you plug negative 3 back into the remaining items, because the remaining items will be these two pieces, if you plug that back into those two pieces, when you plug negative 3 in for these x values right here, that'll produce an answer, and then you will put that right here. Okay? All right, so the domain, you figure that out right up here, right when you factored. Whatever was on the bottom right there that you would not accept, like there should be two numbers that you're not going to let people use in your problem. So that domain is also going to be basically what your vertical asymptotes are. Okay? So once you get your two vertical asymptotes drawn wherever they are, and then you get your, you won't have two vertical asymptotes, you'll just have one because one of them cancels out, right? So whenever you get your vertical asymptote drawn wherever it is, so you got that, you got your horizontal asymptote drawn, and then you're going to go to Desmos and graph the original problem to get the rest of the picture. Now you can use Desmos to figure out that y-intercept, but that y-intercept can also be easily found by just plugging 0 into the original problem. So if you plug 0 in here, 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 look at what's left, negative 9 over 3. So that is easy to find, it's negative 3. So that could be a nice point on your graph that you know the answer to. Okay? All right, with number 2, you can easily see that x squared plus 5x plus 8 will not factor. 4 and 2 make 8, but they don't make 5. 8 and 1 make 8, but they don't make 5. And so nothing happens here. So remember, your domain is going to be all x values, so all real numbers, but x cannot be negative 3, because remember, you don't want the bottom to be 0. All right? There is not going to be, so that is also your vertical asymptote. Remember, x equals negative 3, so you could draw that on your picture, right? You have a nice vertical asymptote at negative 3. All right, and then your horizontal asymptote. Well, if you notice here, the degree of the numerator is bigger than the degree of the denominator. So you are not going to have a horizontal asymptote. You're going to have a slant asymptote this time. All right, so like we talked about in class, so not this, you're going to need a slant asymptote. So for a slant asymptote, I'm going to need to see some long division. Divide x plus 3 into x squared plus 5x plus 8. And, there's going to be a remainder and all that. But what we're interested in is this piece right here. Whatever that comes out to, that is the equation of your horizontal asymptote. Your slant asymptote. So whatever that turns out to be, y equals whatever is right here, that's going to be your slant asymptote. And then you're going to draw that equation. You're going to draw that line on your picture. All right. Nothing cancels. So there is no hole. And I'm pretty sure you can easily pretend that all these x's are zeros, and you can right there see what's left over for your y-intercept. All right, so going on to the last part here, solving equations. So number 3, first of all, you have to decide what numbers you will never accept. So I will never accept, or basically x can never be -4 and 1 in this problem, because -4 would cause this to fail, 1 would cause that to fail. So this is like my domain as well. I will never accept -4 and 1. X can never be those numbers. All right, so this problem just like a good old cross multiplying problem, right? These two and then these two. So I'm going to multiply 3x by x minus 1 and set it equal to 2 times, can't read what that says, there we go, times x plus 4. I'm just going to multiply that stuff out, and it looks like I'm going to need some kind of solving quadratics by the time I'm done. All right, so on this next problem, number 4, you do need to factor this, but if you notice, these two items right here are the thing that it factors into. So when you go to do this problem, you just need to make sure that you are giving each fraction what it doesn't have. For instance, this first fraction, the 4 over x minus 2, doesn't have the x, so you give it an x. The -2, doesn't have the x minus 2, so you give it the x minus 2. And the 14, frankly, has everything, so you don't give it anything. So what you end up with is 4x minus 2 times x minus 2 equals 14, and you have to solve that equation. And so it's just a good old algebra 1 problem that you got to do. Okay? All right, so I'm not going to, I kind of feel like I kind of did that problem mostly for you. Mosquito. Oh, I got him. All right, sorry. Anyway, number 5. So number 5, again, you need to factor this right here, and I think you'll notice that the factors are already right there. So you need to do like you did in number 4. 2x needs to get something to make it the same denominator as the rest. 3 needs to get something to match the denominators, and 27 doesn't need anything. So when you're done, you'll have this problem to solve. 2x times whatever plus 3 times whatever you decided equals 27, because 27 had everything that you needed. And so you're going to have to work that out and solve it. You'll probably need some type of factoring or the quadratic formula to solve it. And that's it.